Could robots actually cool themselves down just by bumping into each other? A groundbreaking discovery suggests exactly that, and it could revolutionize how we control robot swarms. Researchers at Heinrich University Dusseldorf and La Sapienza University in Rome have uncovered a fascinating phenomenon where groups of active robots can automatically come to a stop through a self-sustaining process. The secret lies in something we experience every day but rarely think about: static friction. Here's where it gets interesting. Unlike the friction that heats up your hands when you rub them together on a cold day, this special type of friction, known as Coulomb friction, can actually have a cooling effect. Think about how a box stays put on a slightly tilted surface until it reaches a critical angle. That's static friction at work, and it's the key to this discovery. But here's the truly revolutionary part. When hundreds of small robots move around and collide with each other, something unexpected happens. If the robots are densely packed and moving with just enough force, the static friction during collisions causes them to stop moving, effectively cooling down in physics terms. These stopped robots form clusters, creating what scientists call cold areas among the still-moving hot ones. Dr. Alexander Antonov, the study's lead author, successfully recreated this behavior in computer simulations, confirming that this isn't just a fluke, it's a fundamental physical principle. Professor Lorenzo Caprini emphasizes what makes this so special. The robots cool themselves down through collisions, with no external control needed. This discovery opens up fascinating possibilities. Imagine entire swarms of robots that can regulate their own movement patterns, or new ways to control bulk materials without direct intervention. But here's where it gets controversial. Could this self-regulating behavior be too good to be true? What are the implications for robot autonomy and control? The research team demonstrated this effect using hundreds of 3D printed mini robots on a vibrating plate. Perhaps most intriguingly, they observed something that defies normal physics: areas of different temperatures, moving and stationary robots, existing side by side without equalizing, a phenomenon that Professor Lowen notes would be impossible in equilibrium conditions. What do you think about this discovery? Could this self-cooling mechanism be the key to managing large-scale robot operations in the future? Or do you see potential risks in having robots that can autonomously regulate their movement? Share your thoughts in the comments below. This groundbreaking research was published in Nature Communications, marking a significant step forward in our understanding of robot swarm behavior and the practical applications of friction dynamics.